As you can see, my title, it is Craft Fitting Handwritten Notations Towards Sheet Music Symbol Generation. So I have taken this approach to address the challenge for digitalizing handwritten music sheets. Uh, 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 yeah, did I actually on my video? So sorry.
No, your video is off.
Yeah,
Oh
yeah,
yeah,
sorry.
now we also
Yeah,
see you.
okay. So can I start again or should I?
Sure.
Yeah, so my project is about craft handwritten notation towards the sheet music symbol generation. So, based on my project, my general aim is to digitalize the handwritten music sheets. So, when let's go into the project. So here is the project overview. Um, so this project focuses on digitalizing handwritten music sheets, a critical part of a cultural heritage, we can say. So handwritten music sheets is like a challenging to process due to inconsistency in styles and the quality of the original document. So tackle with these challenges, like I have used an advanced AI model called ESR GAN. So it's like an enhanced super resolution generated addressal network in detail. So yes, Argan is like well suited for this task because it provides a very high resolution image with excellent detail retention. So the main goal is like to improve the OMR and make these music treasure accessible for like a future generation and stuff. So, and why which made me pick this project. So why this project? So my passion towards music and like I'm inspired by AI. So based on that, I just wanted to take this like historical capturing and handwritten scores. As like a data analyst, I saw an opportunity to use like AI to prevent it. So handwritten scores are like unique but often degraded over time, so becoming it too difficult to interpret. So digitalizing these scores is like a way to ensure that this is like accessible for future and for educational purpose and so on. So here is a the literature review I went through to choose ESR GAN. So before starting this project, I reviewed like quite a few papers. So for example, like the Wang et al. This introduced ESR GAN, a model like known for its ability to enhance image resolution and preserve interact details. And Bharat Foundation actually helped me to know about GANs, understand how the network generate realistic outputs and stuff. So like the final is the Lee et al. Shows like how GANs excel in complex image synthesis and task. So based on all of these research, I decided to take ESR GAN. Uh, and a quick review about ESR GAN in particular, like it stands out among AI model because it excels at um, preserving fine details in images, which is like essential for digitalizing handwritten music. And the traditional GANs actually can often introduce artifacts, but actually ESR GAN reduces this while delivering high quality output. So it also incorporates features like residual dense blocks like RRDB, so which enhances the feature learning without losing information. And this also has certain loss functions like perceptual losses and adversarial losses, and so on. So these are all actually help it to keep the pixel level accurate and but also look very realistic overall. And here is a quick architecture diagram of ESR GANs. So it has like three components: the generator, which actually utilizes the RRDB, which also consists of like a convolutional layers and upscaling blocks and downscaling blocks according to our requirement. We can use either of them, and along with that we also have a discriminator equipped with attentional U network. So like it is modeled to focus on important features like edges, and it also has a loss function that is like as I mentioned, like adversarial, perceptual, and pixel losses, which actually guides to train the process to preserve finest details and maintaining the ESR GAN particularly efficient for generating the handwritten music scores, like enhancing them in general. So here is the methodology I have taken to provide this. Like my first step, like I have used CVC music schema plus plus data set, which is has a wide range of like handwritten music notations and stuff. So with that, I have did the data preparation by slicing my images into two slices, and resize them into 256 into 256 pixel. Actually, this is done to match the input requirement of the model and to ensure the generated could like process the smaller detail segmentation effectively. So pre-processing step like contrast enhancing and noise stimulated were actually used ability and replicate it with the real world imperfections. So this ensured like the data set was diverse and well suited for training. So going in detail in the methodology part. So during training, the generator actually uses RRDB to upscale the lower resolution images while maintaining the fine details. And this generated images were like evaluated by the discriminator while comparing it to the original images. So these loss function like adversarial, perceptual, and pixel losses guided the model in like providing the realistic and high quality images. So over 80 epochs, the adversarial training retained the generator and discriminator. So like this is actually done to ensure that the output were like stable for OMR application. So let's like look into the results part. Let me show the outcome. So these are the generated images. And this is like the generated loss and the discriminated loss for ESR GAN. So basically, if we see that the generated loss decreases over time, whereas the D loss, the discriminated loss actually stabilizes. Generated decreases over time. Like this indicates that the generator is improving at producing realistic images, whereas the discriminator stability actually shows that the discriminator is like effectively learning to distinguish between the real and the generated image. And this balance actually ensures that the high quality detail output for the model. And here I have also showed the TSNE clustering part. So this is like I have demonstrated to show like the insights in the model understanding of the data. So the clear separation of the cluster shows that the model has successfully learned to extract and group similar features such as like music symbols and structures into distinct categories. And this indicates that the model is effectively capturing the pattern, and the details ensures for enhancing handwritten music sheets as well. And here is the pix to pix model outcome. So this I have used like a base model to compare like the ESR GAN with pix to pix model. It's actually generally done because I just wanted to show how effective ESR GANs are. Um, so this is the generated images of pix to pix, and here we have again given a graph of G loss and D loss. So if we see that it the G loss and D loss indicates like slow convergence and like more of fluctuation. This reflecting like less efficiency learning and imbalance during training, which impact the quality of the output actually. Let's see the performance comparison. So I have used a couple of scores like MSE, which is like the edge detection one, FID, and IS score. So based on these scores, we can see that ESR GAN has a quite less score compared to the pix to pix, which makes it more compatible than the pix to pix one. So in conclusion, ESR GAN has like improved to be an effective tool for digitalizing handwritten music sheets. So its ability to generate like high quality, detailed images makes it well suited for improving OMR systems. And this project highlights how AI can support the perception of cultural heritage. So looking ahead in future work could like explore like real-time applications and incorporate more diverse data sets to handle various like historical music styles and stuff. So this is like more like potentially like AI is in this domain is like vast, and we can keep on trying new things and stuff. So thank you for your attention. Like I hope this presentation has given you the insight in how ESR GAN has contributed into preserving the music heritage. And I'm happy to answer any questions or discussion. And apart from that, I just wanted to make the point like previously they had asked how this both slices are combined and brought into a full image. So I have done that part. So when I have done that, like in the overlapping part, what I have done is I kept the overlapping quite little, like the lesser amount. If we overlap more, there might be a chances of more of artifacts. So I have tried overlapping with different sizes. So when we overlap with the least size, it actually joins up because it is of the same pixel sizes, so it just joins up and it doesn't give any of the set, and we get the original full image instant. Thank
Thank
you.
you very much. Wonderful. Then it's time for questions. I have a couple, but let's see if someone else also has questions. Maybe one technical question to start. This requirement of 256 by 256 pixels.
Yeah.
I'm not familiar. Where is that coming from, this
Actually, the
requirement?
whole like the data set which I have used, it's like a rectangular one. So I can't give a rectangular one for the GAN because GANs always work with a squared square pictures. So to make that possible, I have tried to compress the whole image as a squared one. But in that process, the symbols or the lines, whatever in the music sheet, it used to become compressed, and when the generator generates, it doesn't like learn in a perfect way, and it was getting confused between the lines, and all the pictures was like messed up. So to rectify that, we split that whole image into two parts and made each as a single slices, and each slices as a squared slices, and I kept it as 256 into 256 pixel. We can keep it of any size, like any squared size. So I chose 256 into 256, and based on that, we gave those images to the generator learns like a separate slice of each image, and then it combines them after generating, and the combined image was given to the discriminator to do the other process.
Yeah, try to reformulate it a bit because I just don't understand why it has to be square. Is there like
Because
a
like
specific?
GAN architecture, it just takes like squared image, because it doesn't take a rectangular one. If it takes a rectangular one, it's gonna become too much complicated, because I did try giving it a rectangular image, and because of the residual blocks and stuff, like it used to get complicated. The architecture used to become too complicated. So mostly GANs take square images. So
Mhm.
for that process, we gave a square image.
I was thinking about the same thing, and I was thinking that you have the discriminator, you have to reduce the image into just a single value, true, false. So I guess if it's a rectangle, you get a vector. I don't know if it's fully convolutional, if there is a fully connected layer at the end, or however the details of the architecture. I guess that might be the reason also.
I did try giving it in rectangle, but it wasn't actually taking the image as a rectangle. So then I got to like I did my research and I got to know like GANs actually perform very effectively when it is like squared images. So we had to do this process to make it like a squared and then make it the rectangle in the end.
Maybe one more a bit technical question.
Yeah,
What is your interpretation of, so when you show the evaluation metrics,
yeah,
you use the inception score, IS, and you use the
yeah,
Fauché-informed inception score, and there was quite some difference between them. So on the
yeah.
inception score, it seemed quite good, but the Fauché inception score was much higher. Is there some interpretation from your side why this is happening?
Yeah, so FID score was like lower in ESR GAN. So if ID score is lower, which means like I have tried a lot of results, so to compare which is good. So IS like inception score was like quite similar for both. So to check whether yes again was really good based on my baseline one, I have done other scores as well. So based on that, in both the scores, like ESR GAN was quite less. So FID score, if it is less, it is like more effective one. So based on that, ESR GAN was working better in other aspects as well.
Just to add, the measures are looking at two different things. So FID is looking more at the distribution of the real and the generated images. And then the inception score looks at the quality and the diversity of the generated images. So I guess that's why like it's learning something better, but in some other things it's not doing as well.
Okay, because I know that the Fauché-informed inception list, there's like, is it that one or is it memory? No, there is like one more, the memory-informed Fauché inception distance. Okay, this is then something else. Okay, never mind. There's like one more thing to this kind of evolution thing of this. Okay, it's fine. Maybe one last quick question. What was the input of your pix-to-pix model?
Input of the pix to pix was like similar to the ESR GAN. Like I did the same thing for the pix to pix as well because I wanted to keep the data preparation and stuff similar to make sure like it works in the same way.